What's up, everybody? It's Austin here. We're going to be reviewing Chem stuff for this Chem class coming up. Hey everyone, it's Austin here coming to you live with the organic chemistry review for organic chemistry. Lewis structures. Now don't be deceived, this seems really easy, but this question throws a curveball and so you have to stay for it to see where the curveball is. So it's going to be a quick video. We have two of these coming. Chlorine tetraoxide, negative charge. Draw the Lewis structure for that. Okay, first step in drawing a Lewis structure is, of course, find out how many valence electrons you have total. So how do you do that? We have chlorine and oxygen. Okay, chlorine is in group 7, it has 7 valence electrons. Oxygen's in group 6, it has 6 valence electrons. So write that down. 7 and 6. Now you have 4 oxygens, so you're going to have 24 total here. You have a negative charge on the molecule or compound, so it's 1 electron also, so you have an electron here. This negative charge means an extra electron. So now we have 7 plus 24 plus 1, we have 32 valence electrons. So now we just draw it like we normally would draw it. The Cl in the middle bonded to 4 oxygens, and we have how many electrons here? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 8 here, 8 here, 8 here. We have 32. So it seems like we're good, right? But we're not good. And this is why. Formal charges. This has a -1 formal charge on it. Now, oxygen needs 6 valence electrons usually. How many does it have here? 1, 2, 3, 4, 5, 6, 7. Remember, this bond is really like this. And oxygen owns one of them, and chlorine owns the other one. So oxygen has 7 valence electrons on it, and it needs 6 usually. So it has an extra electron, so it's going to have a -1 charge. Same here. Remember, 2 electrons, one of them, they're both shared, so one of them owns, like oxygen owns one of them, chlorine owns one of them. So oxygen has 1, 2, 3, 4, 5, 6, 7. It needs 6. It has 1 extra, -1 charge. So all these oxygens have a -1 charge. What's the charge on chlorine? Chlorine normally has 7 valence electrons. How many do we have here? 1 from this, 1 from this, basically 1 from this bond, and 1 from this bond. It has 4. It has 4 valence electrons. It normally has 7. So it has 3 less. That means it has a 3 plus charge because it has 3 less electrons, so it's 3 more positive charges. So it has a 3 plus charge. Now that makes sense because you have a -1, -1, -1, -1, which is -4 plus 3, which is -1 charge. But is there a way to draw this Lewis structure which minimizes these charges? Because this is a lot of charges. 3 plus 1, 1, 1, 1. Can we get rid of those things? That's the question. That's what you have to do to find the best Lewis structure. It also could be considered a resonance structure, actually. So how are we going to do this? We're going to go over here and, hold on, y'all. We need to rearrange this. So what I've done is basically, remember this is how it looked before. You have 1 bond and you have 6 electrons. Here I've removed 2 of the electrons. Let me use my green. 2 of the electrons, and I put it into a bond. So these 2 electrons were here. I removed them and made it into a bond. Now what's that do? Remember, bonds are shared electrons, so now one of these bonds goes here, one of these bonds goes here, one goes here, one goes here. Now how many do we have? 1, 2, 3, 4, 5, 6. How many did we say we need for oxygen? It's in group 6. We need 6. Oxygen now has 0 charge. Same here. One of these electrons is here, one is here, one is here, one is here. That's 1, 2, 3, 4, 5, 6. It needs 6. 0 charge. All the oxygens have a 0 charge now. What's chlorine's charge? Well, remember, now it has double bonds. Each of these double bonds will give 1 electron to each of these. So 1 here, 1 here, 1 here, 1 here. And remember, 1's going here and here. So it has 1, 2, 3, 4, 5, 6, and 8, right? 8 valence electrons. It likes 7 because it's in group 7 on the table. And we have 8, so it has 1 extra electron. So it has 8 instead of 7, so it has a -1 charge. Here's the -1 charge. And remember, the Lewis structure, well, the question said it's a -1 charge, so the Lewis structure will have a -1 charge. So the final way to draw it, which I wish I would have did earlier, is Cl double bonds. Oops, my bad. Double bonds. Why though? Because we've minimized the charges. Double bonds to oxygen. We don't want a bunch of charges on this. I mean, we had 1, 1, 1, 1, and +3. Now we just got -1. That's so much neater. That is the correct Lewis structure and correct resonance structure of chlorine tetraoxide. Now, we don't really have time for this one, but I want to go through NaBH4 real quick. You have to realize that Na is a metal. It's way over here on the periodic table. You have to realize that boron is one of the metalloids. It's not a metal. So you have a metal and a non-metal. When you have two non-metals, you have covalent bonds. When you have a metal and a metal, you can't do nothing. No covalent bonds. When you have a metal and a non-metal, you have an ionic bond. So ionic bonds do not share electrons. So what you have here is Na, which is a plus charge, which is seen here. It needs to lose an electron to be like a noble gas. When it loses an electron, it gets a positive charge. Okay. And how many electrons do we have? This has 1 valence electron. Boron is in group 3. Well, it has 3 valence electrons, and hydrogen, of course, is 4. 1 times 4. So there's 8 total. 8 valence electrons. None will be put here because Na is happy. It is Na plus charge. But this one, BH4, will get all 8. So you have the 4 bonds, so 2 electrons per bond, so you have 8 valence electrons all used up. Everything's nice. What's the formal charges? Hydrogen's in group 1. It shares one of these 2 electrons. So it has 1 electron and it needs 1, so it has 0, 0, 0, 0 formal charge. Boron, it's in group 3, so it usually has 3 valence electrons. How many does it have? It has 1 from this bond, 1 from that bond, 1 from that, and 1 from that. So it has a -1 charge. And this has a minus charge. That's an ionic bond, a plus and a minus. So that makes sense. So that's really messy, but that's basically how you draw it. A B single bonded to all 4 H's, and then you put a -1, and you can put it in brackets, like we did for this. And then next to it, we just put this Na plus. Hope that makes sense. The main thing that is hard to understand is that each bond gives 1 electron here and 1 here. All right, check out the next video. All right, everyone, thanks for checking out the video. Be sure to hit that like button, subscribe, and check out the next video. It's going to be labeled O-Chem 2. It's going to be more organic chemistry. Lewis structure is more organic based this time. This video was not really organic based. Next video will be. So check it out. We out.